Guys, you're welcome to this channel. If you are new here, just click on the subscribe button, and if you are one of the subscribers of this channel, thanks for coming back again. Endeavor to always share a video, comments, give a good comment, and then try to give a like. Thank you. So we want to talk about a topic in physics which is probably very common, so we're just gonna try to talk about the applications. So but before we discuss the application, we need to discuss certain things. That is on the topic is dynamics, Newton law of motion. So let's just take it, physics. So Newton's laws of motion. Good. So as we are saying, we have Newton laws of motion. So and these three laws bind the every motion. This is the law that binds all kind of motion. So when you talk about linear motion, the law is acting. So and you can also convert all the formula that have to do with the linear motion as far as this law is concerned into rotational. So the law binds all kind of motion. So the first law is called the law of inertia. The law of inertia, which is called Newton's first law, states that a body will continue in a state of rest or uniform motion on a straight line unless it is compelled to change the position or stop the motion by an external force. So which means a body will always start moving when a force is applied, and while moving uniformly, the body will stop motion if a force is applied. So this is what the law is trying to talk about. So it's called the law of inertia. So what inertia means is the tendency of a body to remain at rest or in uniform motion. So when you're in motion, there is this reluctancy to stop the motion, especially let's say you're driving, so and somebody match a brake suddenly, so then you get you'll be pushed forward. So this is because of inertia. You've been maintaining that state of motion and then you are forced to stop it. So and then the same thing where you are at rest, that's the reason why you have to be pushed before you move if you don't want to. So this is what the law is trying to talk about. So we have the application as far as driving a car. So the reason why we use the seat belt is because of inertia and so on. So then that is the first law. The second law states that the rate of change of momentum. So what is momentum? Momentum is when you multiply the mass and the velocity of the body. So the velocity, another way around, you can call it speed, but preferably velocity, because when you call it velocity, it shows that direction is indicated and is a vector. So if you call it speed, that means no direction is indicated. So it's better you call it velocity. So now, when you say the velocity is the mass times, the momentum is the mass times velocity of the body. So take for instance, a car want to hit a body with its on, it will have to move to the back a bit. So moving to the back is to give it the allowance to run. So when you run, you have a velocity, which is, let's say, speed, and then the speed multiplied by the mass of the car is what will be supplied to whatever body the car is hitting. So that is what we call momentum. So the same thing happens in collision of cars too. So when mass of a car is multiplied by the speed of the car supplied to a body, so that is momentum. So the rate at which momentum change. So whenever science mentions rate, they have to do with time. So it's talking about time. So that's the time rate. There is a time difference between changing your initial momentum to the new one. So if you are sitting, then you are at rest. So your momentum is zero, because if you multiply your mass, no matter how heavy you are, if you multiply by your speed, it's going to be zero. So now, if you start motion, so there is a time difference between your resting position and your new momentum. So that is the meaning of rate of change. So now the change is you change your momentum with respect to time, because time monitors every damn thing we do in physics. So the rate of change of momentum is directly proportional to the applied force. The meaning of that statement says that when your momentum changes with time, the rate at which it changes depends on the force applied. So if you kick a ball with a small force, the rate at which the ball will move from rest to new momentum will be small. But if you kick it, just like you say you fire a shot, it moves very fast. So the change in momentum, the time rate of change in momentum is faster. So and it depends on the force applied. One thing added to the law is that the body moves in the direction of the force. You cannot play ball to the left and goes to the right. So it has to be in the direction of the force. So which means momentum is denoted by P. So P is momentum. Just like I told you, you can have an initial speed. So let's say U is initial velocity. Then when you change your speed, that is when you start motion, you have V, which is what? The final velocity. So which means your momentum change and your mass is M, mass of body. Are you getting it now? That is mass of the body. So the initial momentum, initial P will be what? mu. Then the final P will be mv. So the change in P is going to be what? mv minus mu. That is the change, just like the change, the final minus initial. So the rate of this change, that is what the law is talking about. Force is directly proportional to the rate of change in momentum. The rate has to do with time. That is change in momentum over change in time. So now, in here we introduce a constant K equals change in P over change in T. So this formula is called Newton's second law of motion. So, and the value of K is 1. So then we can derive more formula from that by putting F equals change in momentum is mv minus mu over T. So which is same thing as m into v minus u over T is still the same. Now, the change in velocity of a body with the time is acceleration. So when your body changes velocity, you are actually accelerating. If you are in a car and you are maintaining a speed, if you maintain a speed for a while, that means you are moving with uniform velocity. When you apply the accelerator to move faster and more faster, when you keep applying your accelerator, your speed is changing. So which means you are accelerating, you are changing your speed. So whenever your velocity change, it means acceleration. So then in that wise, we can call change in velocity over time, we can call it acceleration. So this formula is Newton's second law of motion. You need them. Okay? So and then there is something we call impulse. Impulse is just like the force multiplied by the time. When you can apply a force on a body for a given time, so that is impulse. So impulse is change in momentum. Impulse is force times time and is change in momentum. So even this formula could prove that for us. If you multiply this by t, you have ft, and you multiply the whole thing here by t, you're going to have m into v minus u. So and this we have here is the same thing as this we have here. So and this ft is the impulse. So which means impulse is same thing as change in momentum. So in case you're given a question, you need to calculate the impulse. So it's still the same thing as the change in momentum. But the parameters given will depend which formula to use. Is it force times time or the change in velocity? Okay, let's look at one question that has to do with this. Like the question says, a ball of mass 0.1 kg. So mass of the ball is 0.1 kg. Moving with a velocity that's, let's say, initial of 2 meters per second, then hits a wall and then rebound with the same velocity. So which means the new velocity is also 2 meters per second. So they now ask you to calculate the impulse received by the wall, or sometimes they might ask you to calculate the change in momentum of the ball. So don't forget now that the change in momentum of the ball is equal to the impulse received by the wall. So in that wise, we are not given to calculate impulse. We use force times time. No time is given, no force is given. So that indicates we just need to calculate the change in momentum. So the impulse received by the ball is same thing as change in momentum, and change in momentum is mv minus mu. Good. So now, looking at it now, this is the vertical wall. So if the ball is coming in this direction to hit the wall and then rebound with the same velocity, so which means these two velocities are opposite of each other. That is the reason why I said you should make use of velocity, because it shows direction. So one is going to be negative and one is going to be positive. So let's assume this one going to the positive side of, like, in x-axis. So this is positive x, this is negative x. So the rebounding velocity would be negative 2 meters per second, while this one would be 2 meters per second. So which means we can write the formula. I just have to make this the inertia. I don't want to get a negative answer because momentum cannot be negative. So the change in P is going to be, or let's say the impulse is going to be mass, which is 0.1 multiplied by 2 minus, then this will be minus 0.1 times 2. So which means I'll be having 0.2 plus 0.2. So the impulse received is going to be 0.4. Then you can put your unit as the unit is kilogram meter per second. So that is the impulse received by the wall, or the change in momentum of the ball. So these are questions that could come, and we have varieties of questions that will require you to use F equals m into V minus U all over T, and so on. So now let's dive into Newton's third law of motion. Newton's third law of motion is trying to tell us that action and reaction are equal and opposite. So which means for every action, there must be an equal and opposite reaction. In the absence of that, it leads to destruction. Take, for instance, trying to carry a bag of rice on a table. Okay, let's say the table is strong enough to carry it. So then if you put the engine of like a truck on such table, you know, the action of the engine on the table must be able to give an equal reaction, so that there will be balance and there will be no destruction. So if the table could not give opposite reaction, equal reaction, because the reaction should be directly opposite. So if you're bringing a body on this, so whatever you are placing it on should be able to give opposite reaction to hold themselves. So now, if this could not give, is giving equal but not opposite reaction, is going to lead to destruction. The table is going to break. So the same thing happens when cars are colliding. So when a big car is colliding with a small car, so then you discover that the small car will get totally destroyed, because the actions and reactions are not equal and opposite. And that is not the only thing. It's not about the masses alone, it's about the momentum. So the momentum, even when you have the mass of a truck, even when a car is coming from a distance for a very small car, hitting the truck is going to lead to destruction of the car. So which means the momentum of the car is not still enough to meet up with the mass of the truck. So this is what the third law is trying to talk about. So then we will dive into what we call the law of conservation of linear momentum. So the law of conservation of linear momentum is just like the application of Newton's second and third law. So, and then what that law simply states is that when two bodies collide, you know what collision is? When two bodies come together with great force to hit each other. So the algebraic sum of their initial momentum before they collide must be equals to the algebraic sum of their momentum after collision. So let's say you have two round balls of mass m1, this one moving with a velocity of u1. U represents the initial velocity, and then this one is probably at rest or moving in the same direction, but this is faster than this, and this one could meet up with this and hit it. Or let's say it is at rest, so m2 being at rest, that means you still also have a velocity, but it's 0. Now this is before collision. So before collision, the momentum of this is m1u1, the momentum of this is m2u2. You are going to add it. Now after collision, two things can occur. It is either they stick together and move together, or they eat themselves and separate and move separately. So if they stick together, such collision is inelastic. So and then this we have a velocity, the mass m1, m2, but they share common velocity because they now move together. So the momentum after collision will be m1 plus m2 multiplied by v because they are moving together. So what law of conservation of linear momentum is trying to tell us that m1 u1 plus m2 u2 will be equals to m1 plus, okay, let me put it here, m1 u1 plus m2 u2 equals m1 plus m2 into v. That is what the law of conservation of linear momentum is talking about. So good. Having this is an inelastic collision. Then you can also have elastic. The elastic collision is just like when the two bodies hit one another and they separate and move in their respective directions. So let's say after collision, when they hit, this one moves back with velocity v1 and this one moves like this with velocity v2. If they move in opposite direction, don't forget the negative vector we had. So then the momentum here will be m1 v1, this will be m2 v2. So adding them together and equate to this using the law of conservation of linear momentum, we have m1 v1 plus m2 v2. So this collision is called the elastic collision because the two bodies move separately. So we have a lot of questions that comes in terms of this. Okay, now let's answer a question. So like the question says that a bullet of mass 0.1 kg, that's the mass of the bullet, traveling with fired with a velocity v of the bullet, okay, let's say u of the bullet, initial velocity of the bullet with 100 meters per second. Now hit a wooden block. So let's say the mass of the wooden block is not yet given. So hit a wooden block at rest. So which means the initial velocity of the wooden block, okay, let me wooden block, is 0 meters per second. Are you getting it now? So a bullet of mass 0.1 kg is fired with this speed and it hits a wooden block that is at rest. If the block shifts with a velocity of 10 meters per second, so which means, okay, if the bullet is embedded in the block and the block shifts, when they say the bullet is embedded in the block, it means the bullet and the block are into each other and the bullet gets stuck into the block and then the block shifts. So that type of collision is inelastic. It's obvious because the bullet did not go its separate way while the wood goes its separate way. So they're together moving. So there are different situations. You should know the formula to use. So now, so if the wooden block now move with the velocity of 10 meters per second, like by shifting away from the position, so then we are told to find the mass of the wooden block. So it shows that this velocity is for both the bullet and the wooden block after the impact. So we use mb ub plus mw uw equals mb plus mw into v because the collision is inelastic. So that will be 0.1 times 100 plus, since the initial velocity of the wooden block is 0, so mass times 0 would be 0. Then we'll be having the mass of the bullet is 0.1 plus mass of the wooden block, which we're looking for, multiplied by 10. So having this will give us 10 when you multiply this plus 0 equals 0.1 plus mw into 10. Don't waste your time opening the bracket, just divide here by 10 and here by 10. So then you have 1 equals 0.1 plus mw. So taking your 0.1 to the other side, I think you have 1.1 kg equals mass of the wooden block. So the mass of the wooden block is going to be 0.1 kg. So we have varieties of questions that could come on it. So then you just try to trash them up. So now let's talk about the applications of Newton's law, the three applications. Okay, like the application of the three laws. Applications of the laws. So in the second law of motion and the third law of motion is applied in shooting a gun. When you shoot a gun, probably you see a soldier shooting a gun, there is this recoil that takes place in the gun. So the momentum of the bullet that is out is the same thing as the momentum of the gun, because when you shoot a gun and the bullet moves out, there is a recoil of the gun. So the gun shooter will experience a backward pull due to the recoil of the gun, and this backward pull comes with a certain velocity, so which we call the recoil velocity. So in the application of this law and the law of conservation of linear momentum, when the bullets exceed the gun and is traveling its way, the momentum of that bullet must be equal to the momentum of the gun, and the momentum of the gun is the mass of the gun times the recoil velocity. Meanwhile, the momentum of the bullet is mass of the bullet times the speed the bullet is moving. So there is a formula to represent that. That is a recoil of a gun. So which means mass of the gun is big M, the recoil velocity of the gun is big V, all equals to let's say the mass of the bullet multiplied by velocity of the bullet. So in case of incasity, you might be given questions where you have to find mass of the gun, mass of the bullet, or velocity of the bullet, velocity of the gun. So we can write it as this is recoil velocity, this is velocity of the bullet, this is mass of the bullet, this is mass of the gun. Okay, let's call the recoil as velocity of the gun. So this is application of that law. Then we also have other applications like jet and rocket propulsion, jet and rocket propulsion. Now, when you are getting rockets into maybe to move out of the space, it makes use of fuel, and this fuel supplies a certain amount of energy per second to the rocket. So this fuel and the energy supplied is giving the rocket the force to move out. So there is a way we calculate the force applied on the rocket using the amount of fuel used, the amount of fuel that is burned per second. So we can just put that at the momentum of the rocket is mv. So where m is m is mass of rocket and v is velocity of rocket. So the force applied by the fuel, by burning the fuel, is equal to the momentum of the rocket. So now, how do we account for this force? We can account for this force. Now we know the mass of the rocket and we can know the velocity of the rocket. So how do we account for this force? This force F is equal to mass of fuel burned per second multiplied by, when the fuel burns, it burns and gives us a gaseous exhaust. Like you see gases coming out when a rocket is being launched, if you have ever watched that video before. So the speed at which the gas moves out, that's the velocity, is v. So mass of the fuel burnt per second times velocity of the gases. And the gases evolve as a result of burning the fuel. So the gases come out with certain speed. So that speed multiplied by the mass of the fuel that is burnt per second will give us the force that is applied on the rocket to give the rocket this momentum, mass times velocity of the rocket. So then we also have the application in terms of body in a lift. Law is applied in when we talk about the weight of the body in a lift. So if you want to calculate the weight of the body in a lift, you can make use of the application of this law. Now, you should be able to differentiate between when the lift is accelerating and when the lift is moving with uniform velocity. So acceleration is when your velocity is not constant, you are changing it with respect to time. So then when you are moving with a uniform velocity, there is no acceleration at the moment. So if the lift is moving with uniform velocity, that means no acceleration, and then or probably the lift is at rest. So the weight of the body W will be same thing as F, and F will be mass of the body times gravity. So the weight of the body W will be this. That is when lift. This is when lift is at rest or moving with uniform velocity. Yeah. Now, when the lift is moving upward, if the lift is moving upward, now you are going to see that the total weight of the body will be the mass times gravity, mass of the body times gravity, plus mass of the body times the acceleration the body takes to move, the lift takes to move upward. So which means when the lift is moving upward, that is ascending. So that is when the lift is what? Ascending. You are going to be having m into g plus a. When the lift is now moving downward, if the lift is moving downward, this is when it's descending. Now, downward movement of the lift could be that the lift is moving with the acceleration. That is, when they say moving downward, that means it's accelerating. So we have to put the word acceleration. So accelerating downward of the lift, if the acceleration is greater than acceleration due to gravity, so the force applied on it will be ma minus mg, because the acceleration is greater than the acceleration due to gravity. But if the lift is moving downward with acceleration less than gravity, it's going to be F equal less than acceleration due to gravity, it's going to be mg minus ma. So the two formulas could be m into a minus g, and you have m into g minus a. Now the last situation is if the lift is moving downward without a control. That means the lift is not controlling itself, so definitely the lift will be traveling at the acceleration due to gravity. It is possible for a lift to control itself upward. That is when it's ascending with a given acceleration. So the sum of acceleration due to gravity plus the acceleration of the body times the mass of the body, we give the sum of, like the formula I gave, mass of the body times acceleration due to gravity plus the mass of the body times its acceleration it takes to ascend, we give you the force or the weight. So now when it's moving downward with its own controlled acceleration, we have discussed the situation. That is, if the acceleration is greater than acceleration due to gravity, you have this. If the acceleration is less than acceleration due to gravity, you have this. Now, if the body is now moving down without control, there is a possibility a lift caught, or probably one thing happened and the lift is moving downward without control. So that's a very that situation. So the lift will be moving at acceleration due to gravity, so no controlled acceleration. So the force there is going to be what? Mg minus mg, which is equals to 0, because the mass, the body in it is not moving with a special acceleration, it's moving with g, and the lift itself is moving with g. So we believe that the acceleration of the body is due to gravity, and there is no extra force applied by the lift. So these are the applications, and you can have various questions solved on it. So thanks for watching. We meet in the next class, and endeavor to share this video and subscribe to this channel. Thank you.